Then I will get started with the presentation, Building Accessible Experiences with AI. So hello, everyone, and thank you so much for joining my session. I wish I could be in Munich right now, but I am here at home. Today, I want to talk to you about how you can use AI to build experience accessible software. Click. Perfect. So, but before we start, did you know you can follow this presentation in about 100 languages of your choice? So if you open this link you see on the screen, I will show you how it works before we get started. So you can go to translator.microsoft.com. The website looks like this. You can start a conversation or you can join a conversation. You can join a conversation, but we will start one. So I'm here and I've created a preset. I just have to click the button start, say start. And now if I click the button right, it's starting the session and it should automatically start transcribing me. So hello everyone, and now you can see everything I say typed here on the screen. So you can follow this along in an app or on the website, and you can choose your language. So this tool will automatically translate it for you in your language, and you can actually make the app read this to you in another language. So you can mute me and put an AI voice on if you want to. So I'll let this run in the background. You can go to this link, translate.it, and then this code RTGWY, and follow me along and see how the AI is transcribing me. So once again, hello everyone, and thank you so much for joining this session. My name is Henk Boelman. I'm a cloud advocate at Microsoft, and I'm focusing on the topic AI and data. So my job is to kind of help everyone to be successful with their workloads on Azure, everything concerning AI. You can follow me on Twitter at @hboelman. I share a lot of things about AI and about events. I have GitHub with lots of code samples about AI. And of course, there is my blog where you can find all kind of articles about, of course, AI, but also machine learning and very specifically Azure machine learning. But in this session, I want to show you some building blocks that can really help you to make your applications more accessible. But why? Why do you want to make your application more accessible? So the answer is quite obvious when I read it. There are over 1 billion people worldwide with disabilities. So by not making your application accessible, you exclude 1 billion people on this planet. And disabilities are can be a very wide range. So there's visual, hearing, cognitive, speech, mobility, neural. Some are very obvious and some are very hidden. And some diseases even combine multiple of those disabilities. So if we look at disability, we often hear people saying that it is someone's personal health condition. But if you rethink that, it is actually a mismatch between human interactions. It is the mismatch between someone's abilities and the way we set up the environment. It is a human-made problem, and it is not something someone has to overcome. So wheelchairs don't make the building accessible. Putting stairs in and not an elevator make the building more inaccessible. And maybe one of the biggest reasons, we're all going to be disabled someday. Some just beat us to it. And that's actually true. So we're also doing it a little bit for ourselves. So in my eyes, accessibility is the design of products, services, and environments so that everyone, including people with disabilities, can fully experience them. And if you design for accessibility, like the first audiobooks were invented for blind Americans in the 1930s, and only used by blind people. It is now a better experience from everyone. Now everyone can experience those spoken books. And there are also a few things that came from these inventions to be more accessible. So Immersive Reader is designed for dyslexia. The blurred background in Teams was actually designed for deaf people and people with ADHD so that they could focus on the face of someone and not being distracted by the background. Captions and transcriptions of the meetings, people that have trouble following the conversation in English, people who are deaf. Video recordings to be more inclusive for time zones, and the hands up and emojis is just a good thing for all. So let's talk a little bit about how we can make sense of the world with computer vision and through speech recognition. So but first, let's see a little bit about what is available on Microsoft Azure concerning AI. So we have this top layer of Azure Applied Services. These are ready-to-use services like the Azure Bot Service, Azure Video Analyzer, Cognitive Search, Immersive Reader. These are products you can use and customize. These products are built on Azure Cognitive Services. These are the APIs that have like a very specific task, so language, vision, decision, and speech. And then if you need to train your own models, you can use Azure Machine Learning to do that and then build on top of that. So Microsoft Cognitive Services, this is where we're going to find these services that can help us build these accessible experience. So there is vision to make your application see, speech to make your application listen and talk back, language to understand what is being spoken, and knowledge if you want to give your application a brain. So enough talking of me. So let's start some demos. So I have my demos prepared in a Jupyter notebook that I'm running in Visual Studio Code. The programming language I'm going to use is Python. So this is a Jupyter notebook, and I'll start off with importing a lot of dependencies. I have set up my API, my computer vision API, because we're going to look at what is on images. I'm creating a computer vision client, and now I can start sending images to this API, and the model or the software running in that API is going to tell me what it is going to see on those images. So I'm sending an image, and we're going to send this, nope, not like that. We're going to send this image to the API. So imagine you have a camera, you take a photo and want to know what is going on. And this is what you see. So we can send this image to the API, and it is going to tell us what it sees. And that is people sitting on benches in a city. And this is like 40% sure. So that is kind of what it is on the images. It's a very general description. But it can do more. It can actually start recognizing objects and things in the image. So it sees a person, a bicycle, it sees our weird Dutch bicycles, children bicycles, sees some persons here and a person there. So now we have an even better idea how what is there. We see some persons and some bicycles. But sometimes that doesn't really work, or it works, but it is not the result we want. So here we have an Indian banknote, and it doesn't say this is a banknote. No, it says there is a person on this banknote. So if we want to train a model that can classify our own objects, we can start using the computer vision, the Azure Custom Vision service. With this service, we can upload a bunch of our own images, train a model, and then have an API that can very specifically tell what is on that image. It can just classify that or do object detection, depending on how much how much images you have. So I'm going to show you the code. We're not going to wait 10 minutes for the model to train. So we're going to run through the code on how to do that, and then go to the Custom Vision AI service where I will show it visually and where we will test it. So you start with training keys and prediction keys. These resources, again, you have to create in Azure. Then we're going to connect to a Custom Vision training client. And when we are connected to this Custom Vision training client, let's do that. We can ask, give us a list of all the domains in which domain you can all train this model. So there are general domains, and there are also very specific domains for food, landmarks, retail, and logo and products on a shelf. So the first thing you do is choose a model, choose a domain that is closest to the one you want to classify or what you want to build your model on. So in our case, we're just going to go for the general domain because it's a very general problem what we want to solve. You see here the words compact. If there is the word compact behind the model, the domain name, you can export these models later on. Normally, the model is exposed to an API, but now, if there's the word compact, you get an export button. And if you click on that export button, you will get the choice of, you get a few choices for that version of the model. You can download it in CoreML, in TensorFlow, in Onyx. You can even get a Docker container where it is running in a fully packed API for you. It actually behaves the same as the API that Microsoft provides. So we pick a domain and we create a new project. Then we start uploading all the images in batches of 64 to the Custom Vision service, and then we train the model. This should work. I can show you the dataset. So this is the dataset we're using. And it is not a very big dataset. There are around 10 to 15 images of every banknote. So the model will not be that good because the recommended size, the amount of images is 50 per class, per object. And then we start training. So this takes around 2 minutes. When we're done with the training, we can publish the model, and then we can start sending predictions to it. This probably doesn't work, but you never know. No, exactly. That doesn't work. No. So let's go to the Custom Vision website, where we are going to have a look. So this is the project I trained a few days ago with the same data set as that we were showing there. So here we see on the left all the classes, and here we should be able to see all the images that I have uploaded. On the performance, we see the iteration. So every time you can change images, you can add, you can remove, retrain your model, and that is called an iteration. We'll see them all here, and you can publish multiple iterations. So here we have precision, recall, and we see here the different image counts. So there are 20 per image. So the good thing is that I used balanced classes, meaning that from every category, from every class, I have roughly around the same amount of images. So what you don't want to do is upload like 100 images of a 20 node and 10 of like a 100 node, then your model will not work. Under predictions, we can actually see the predictions that our model has made. So here we see that it classified this one as a 50 node. Here we can see that this one is classified as a 500 node, which is absolutely wrong. It is actually the 10 node. So what we can now do is add these images back to the training set, tag them correctly, and retrain our model, so our model will become a little bit better. So here we see they do a good job. Yeah, 200 node at 67%. So that is quite nice. So this is very quickly how you can train your own models. Let's get back to this. So now we can see what is on the images, but it would also be very handy to see who is on the images. So let's take a look at this image. This is our prime minister when he was still smiling, and this is someone else I don't even know. So what we can do is use that same computer vision client and analyze image in the stream and detect faces. And let's see what it has to say about these faces. Setting it off, and here it is saying, hey, I'm seeing a male 48 years old and another male 49 years old. But that is kind of cool. But then let's see if they are famous. So the computer vision API can detect celebrities, and if you're famous enough, then it will actually give you a name. So this is Mark Rutte, and this person is obviously more famous than I maybe should know it. This is Steph Blok. But we can get more insight on those faces we see on the image. And for that, we can use the Face API. So let's create a Face API endpoint. Again, this is an API I've created, and a resource I've created in Azure and retrieved the key. I have a Face client, and I can send the same image or this image to that endpoint. So what we are going to do is trying to detect who is on this image. So let's run this image through the API. And here we can see what it has detected. So it is detected, look here, it is a face ID, it is smiling, he doesn't really need to shave, he's not wearing glasses, not wearing makeup, he is very happy. Here is Alex, he is wearing, actually reading glasses, she's female, 26, we will not know. And she is also very happy and she's wearing makeup. And we have done that for all the faces, but we don't have a name yet. So now we only have a face ID, and I would like to train my own model so that it can really detect, hey, this is Luke, this is Alex. So what I have here is a bunch of training images of these same persons. I can create a group. In that group, I can create a person, give it a name, and then I can start adding photos to this person. I'll hit the train button, and it will actually train my model. So now what I can do is I can actually start detecting people. So first I'm going to ask, hey, did you see faces on the picture? Gives me some IDs of people, and then I'm going to match them against my face group. And here we see that it has translated those IDs into names. And finally, we will show it here on an image, and we see that we can now detect Luke, Claire, Phil, Alex, and Haley. But it's cool that we can see who is on the images now, but sometimes it is text, and we just want to know what this text is. So here we have a banner. So it'll probably detect Satya, but it will not say what is on this image. So we can run this through the computer vision OCR endpoint and extract this text. We have extracted the text, and now we can actually display the result. So here we see all the lines it has detected, and as an extra bonus, we get the exact locations where this text is actually positioned. So we can draw borders around it, or actually extract it and overlay it with something with the translated text. Can also do the same for handwriting, also my handwriting. So let's do that. So accessibility empowers everyone. And here we have also the lines and borders. So with Vision and a few APIs, we can do a lot of cool things to make sense of what we are seeing for people who are not seeing. So the computer vision can describe images, detect objects, detect faces, detect celebrities. The custom vision can actually train our own model to classify our own products. And the face API can describe faces and images. We can train our own person groups and identify persons in an image. So that is really cool stuff. So we have 15 minutes left. So I'm going to go quite quickly through this next demo because I want to show you a few other demos which I think are way more interesting than this one. So making sense of the world around us through speech. We start with importing our dependencies, and we're going to play around with this sentence. So this API can just, the voice name, we're going to use this one first.
Accessibility empowers everyone. Accessibility and inclusion are essential to delivering our mission to empower every person and every organization on the planet to achieve more.
So this is really cool. This API can, with 5 lines of code, can speak any text you give it. But this kind of sounded a little bit computerish. So there are these new neural voices which actually sound a lot better.
Accessibility empowers everyone. Accessibility and inclusion are essential to delivering our mission to empower every person and every organization on the planet to achieve more.
So this is super cool. So now we can actually talk back. So let's take a look at speech translation. Because this API you can talk to, and then it can actually real-time translate you in like any language you want. So what we can do is, let's add an external language here. I hope this is correct, but we'll see. Accessibility empowers everyone. In Dutch, it is kind of okay. I don't know how the German is, but this is what it can actually do. And of course, you can talk way longer and have this displayed in a different way. So now what we can do is we can actually let this API listen to us, translate us, and then synthesize those translations back to us. So let's do that. Accessibility empowers everyone. So we have a Chinese version here. So let's play those audio.
Accessibility empowers everyone. Toegankelijkheid en drijft iedereen aan. 可访问性和为每个人提供支持。Accessibility empowers.
You don't really listen, it should be empowered, but still you get the idea. So let's move on to some more applied AI services. And I just want to show you this Azure Media Service thing, because we have seen these building blocks, and now we're going to see how these building blocks can be implemented in certain services. So we have Azure Media Service here. Let's go for more demos. So I've already created an Azure Media Service, a media service endpoint in Azure. And you have the ability to live stream here. So let's add a live stream. We will give it a name. Oh, go in. We will just call it conference. We will say that we do use premium encoding. So we have a full HD stream. We're going to use RTMP as an ingestion point. We can let it generate a host name, and we will actually start it. And we do have all the rights to start broadcasting. So next, you can restrict the input and preview access. We're not going to do that, but we're going to enable live transcriptions. We're going to set it to United States English. We're going to go to next, create. So now we're going to create, it's going to set up this endpoint just as that you would do like a YouTube live stream. But this one is actually captioned real-time, transcribed for you real-time. So let's click on conf and create an output. So you have to do a little bit more than just click, 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 and your live stream is set up. You actually have to define how you're going to deliver this live stream. So you're going to create an output. We're going to use all the default settings, and we're going to create it. So now we are able to actually view our live streams. And we can handle like 1,700 concurrent users on it because I'm using a CDN. So now let's copy this ITMP link, go to OBS, go to settings, go to stream and add this here, add the streaming key here, start streaming, play the movie. We don't see any sound, but here it starts streaming. And what we should be able to see very soon is, no, we're not restarting. We're just going to wait patiently. I say we wait patiently. It always takes like around 30 seconds for the stream to warm up. So here we have the incoming stream, and we should be able to see here the output stream, which is actually working. So here we have the streaming URI, the manifest file, and we can use the Azure Media Player to play this file. So I'll put it here, and then we can add a caption track. We will call it English, and we have to specify the locale, and we can say update player. And now we should be able
You have more power at your fingertips than entire generations.
So now we see that my live stream from my OBS here is being captioned in real time in full HD quality. In this player, you can just get the source code and embed it on your website. You can customize it. You can do whatever you want with it. So this is super cool. And you saw that we could handle 1,700 concurrent viewers. And this is only the basic endpoints. You can add like a lot of more streaming units, so you can go very, very global. So let me stop this here, and let us stop the live event. And the good thing is that captioning an event only costs €4 an hour the last time I looked. So that is super cool, and you have the captions available afterwards in your video. So another thing is, when you want to make your videos more accessible after the fact, you can use Azure Video Analyzer for Media. Before it was called Video Indexer. So what you do is you start uploading your videos, and then let's click the Global AI. The Global AI Bootcamp is coming up. We can load one of these videos, and of course my session is expired. That never happens. And we log in again. So here we see my library. Let's pick this one, the Global AI Back Together keynote. I will actually mute. No, go in. So what we can do is here, when it runs through the indexer, it detects all these cool things for you. It detects who is on the image. So here is Sami. Sami is in this part of the keynote. Jen is mostly in this part of the keynote. We can give those people names and actually train this model to recognize these people. It is about topics, audio effects, named entities. Everything is there, and it was actually cutting up all these different scenes for us automatically. All this information is available through APIs, so you can automate this kind of wall thing for you. But what is really cool is that I can say here, show everything in German. What that then does, it is also translating this whole timeline. And I now automatically have German captions on it. It's computer generated, so it is not perfect. So that is why there is an edit button, and you can actually edit these captions here by just click edit, and you can start editing them here, blah, blah, blah. The cool thing now is that you can actually download these closed captions as SRT files and upload them to services as YouTube. You can also include audio effects, so it will also say like, hey, there is a door closing and so on, to even make your stream or your on-demand videos more accessible. So all super cool things that you can do with these AI services. And as you see, Video Indexer is really built on top of all these different APIs I've showed you in the past half hour. So to close off, Seeing AI is a great app where all these services also come together and help make sense of the visual world around us. So before we close off, I want you to start asking questions when you're building software. So before you start building or before you get kicked into a project, ask yourself, who am I building this for? And am I building with people? Bring people with disabilities in the design phase of your product. Help them, put them there to help you make an accessible experience, because how good you try, you will never know. And don't bring them later on into the test phase. And don't think as accessibility of a requirement, not solutions. Who can experience what I'm building? Deaf, blind, limited mobility. One thing you can do now is when you do a presentation in PowerPoint, go to the tab Accessibility and click Investigate. It will tell you all the things you can just do now, like adding alt text to images, captions, transcripts, recordings, accessibility checker for your website. But it will tell you also, hey, this contrast is like really hard to read. Maybe you don't want to do this color, these two colors together. Make the contrast a little bit bigger. And who am I unintentionally excluding by doing what I do? And when you're doing something, just make sure everyone has a way to participate in what you're doing, in your events, in your streams, in your software, or whatever you're building. And are your accessibility features available to everyone? And can you actually find them? And so you can advertise, like make a tab, accessibility, show what things you have done, what is available, and put them on by default. Don't hide them away in a very obscure menu. Show them. And when you deliver a service, always ask, learn from feedback, and do better next time. So the more inclusive you are, the more innovative you can be. Together we can create a better and more accessible world for everyone. So I want to thank you all for joining me today. If you want to look at my notebooks and see how these services can work, go to ak.ms/Henk/accessible-AI. And if you have feedback on this session, please go to ak.ms/acc-fb from feedback. And follow me on Twitter, of course, GitHub, or read my blog. Thank you so much, and I hope you have a nice day.